Good morning. Is the audio clear? Let's start. Okay, let some other students also join. Only 2 students are there. Let's start. Yeah, let's see. So now today we will study the remaining concepts. One is conditional probability and another is Bayes theorem. Let's see. So first we will study what is this conditional probability. Let's start. So what is this conditional probability? Let's take one example. Let's assume you are playing, you are giving some exam, and some exam is there and 4 options are there, A, B, C, D, 4 options are there. Okay, and now the options have like this 1, 2, 3, 4. These are the 4 options. Okay, so you are giving this exam but you don't know this question. Okay, how to solve this question? Okay, you don't know anything about this question. So if you do not know anything about this question, then what will happen? You have 1/4 probability of getting the correct answer. You can see the probability of getting the correct answer is 1/4 because you have 4 options. So these options are your sample space. Your sample space has A, B, C, D. These are your sample space. These 4 options are your sample space, and now the correct answer, let's assume the correct answer is this. Let's assume the correct answer is this, but you don't know this. Okay, you don't know. So what is the probability that you will get the correct answer? That will be 1/4. Now let's assume that you have a friend, and your friend is also sitting your friend is sitting behind you, and you are asking your friend to let you know the answer. Okay, but your friend can only tell that the answer is even. Let's assume, okay, somehow he has told you that the answer is some even number. Okay, this is the answer, some even number. So now you know that the answer is even number, the answer is not an odd number. So now automatically these 2 options have, you can automatically, what you can do, you can just discard these 2 options because you know the answer is even number. So now the probability that you will get a correct answer, that will be 1/2. You can see, because you have only 2 choice. Now you are a smart student, so what you can do, you can just discard this option A and option C. Now you know that the now if you basically mark any random option, okay, you mark it, then the probability that you will get correct answer will be 1/2. Okay, because you have 2 options now. These are the 2 options that are remaining. So this is called conditional probability. See, earlier the probability of getting a correct answer, probability of C means getting a correct answer. Okay, this what is this event C? See, our sample space is this. Our sample space is A, B, C, D. This is our sample space. Okay, let's write the event. I am going to write an event, and the event is R. R means right solution. Okay, right solution. So the event is basically getting the right solution. This is the event, getting the right solution. And you know what is the right solution? Right solution is option B. This is the right solution. So this is your event. Okay, now if you find the probability of R let's assume you want because this is your sample space. So now if you find the probability of r, then what it will be? It will be 1 by 4, because this is your event is getting the right solution. This is your event. In this event you can see the basically the number of favorable cases. Number of favorable cases is 1, because this option B is correct, so this is the favorable case, and these are the total cases. So this is your probability 1 by 4. This is your probability. Okay, but now you see the situation has changed. Okay, of course, you were sitting in the exam for half an hour. For half an hour this was the probability 1 by 4, but you were afraid of the negative marking, so you did not mark it. So you were just sitting there hoping that someone will let you know the answer. Somehow you can do the cheating. So anyway, so half an hour you just you know that the probability of getting a correct answer is 1 by 4, and the probability of getting a wrong answer is 3 by 4. So you can see you were very afraid of marking any option. Okay, because you can lose marks, you can get a negative marking. But now the situation has changed. Your friend has told you that the answer is even number. So basically what has happened? This has happened. The event f has occurred. The event f has, what is this event f? Event f is even number. So even number means basically now your event f has occurred, means option B or option D. This is your event f, option B or option D, because what is your event f? Event f is basically even number. This is your event f. Now your friend has told you that answer is even number. So it means that this is the new sample space. Actually this is the new sample space. Why? Because now these are the two options that are possible, B, D. A and C, these are not possible. I told you what is sample space. Sample space is set of all possible outcomes, set of all possible answers, set of all possible. So now the possible answers are B, D. These are the possible answers. So now this is your new sample space. Now if I ask you what is the probability now, so basically I am going to ask you what is the probability of getting a right answer given that you know that f has occurred. Basically now see here we are asking what is the probability of getting right answer. So this was 1 by 4, but now I am asking what is the probability of getting a right answer given that we know that this f has occurred. Basically given that you know the answer is even number. So now the situation has changed. You can see earlier this 1 by 4 was the probability. Now the probability is nothing but 1 by 2, because now the new sample space has two elements. This new sample space, this has only two elements. So now the probability is 1 by 2. So earlier the getting right answer probability was 0.25. Now your probability has increased. So you can see now this is your probability, this is your new probability. So this is conditional probability. What do we mean by conditional probability? Conditional probability means you know that something has happened. Okay, like here you know that even number is the answer. So you have additional information about some event which has already occurred. Okay, you have additional information basically about the event that has already occurred. So basically what is happening, let's assume this is your sample space. So S is your sample space. You want to find the probability of E. What will be the probability of E? That will be the basically cardinality of E divided by cardinality of S, because this is your sample space. So the probability of event E will be number of favorable cases divided by number of total cases. Now the situation is changed. Okay, the situation is changed. You know that F, there is an event F that has occurred. Event F has occurred. Okay, so this event F has occurred. Okay, you know this additional information. Here you do not have additional information. Now you have the additional information that F has occurred. So your probability will change basically. Okay, your probability will change. Means now what I am going to find, I am going to find what is the probability of E given that F. So this is how I will write. Okay, how to read it? We will read it like this: probability of E given that F. So we will write like this: Probability of E given that this arrow means given that F has occurred. So this is our conditional, this is called conditional probability because we have a condition that F has occurred. Now what is the probability? Okay, so this is the, now this is our question. Let's see one more example. Let's assume you are flipping a coin 3 times. Okay, so you are tossing a coin 3 times, and now let's assume that this is a fair coin. So what is the meaning of fair coin? Fair coin means basically all the outcomes are equally likely, all the outcomes have equal probability. Okay, so this is a fair coin. Now if this is a fair coin, then total your sample space has total 8 elements because you are flipping a coin 3 times. So total how many outcomes are possible? Total 8 outcomes are possible. Maybe tail, tail, tail. Okay, maybe tail, tail, head, maybe tail, head, tail. So this is how you can make total 8 outcomes are possible. So this is your sample space. Your sample space has total 8 outcomes. So all these outcomes are equally likely. Now if I ask you what is the probability that you have, so basically now I am asking what is the probability that you have to at least 2 head, means at least 2 head. This is the question. What is the probability that you have at least 2 head? So what will be the answer? The answer is very easy. You want to find the probability of at least 2 head. So the same thing, what you can do, number of total cases, so number of favorable cases divided by number of total cases. What is number of favorable cases? You want at least 2 head. So either you can have this type of situation, or you can have this type of situation, or you can have this type of situation, or you can have this type of situation. So these are the 4 favorable cases because you want at least 2 head. So these are the 4 favorable cases. So your probability will be 1 by 2. This is your probability. But now what has happened? Let's assume what has happened. Someone told you that the first, when you are flipping the coin 3 times, first time, now basically event F has occurred. Let's call event F. This event F has occurred. And what is this event F? Event F is the result of first toss is head. The result of first toss. So basically I can say result of first toss is head. This event F has occurred. Let's assume someone told you that the result of first toss is head. So this is the event that has occurred. What is this event? This event F is basically the first result is head. So now basically these two could be anything, we don't care. This is your event F. So you know that event F has occurred. Now if I ask you what is the probability of getting at least 2 head, given that F, you know that F has occurred. Basically this event F has already occurred. You know this thing, that this F has already occurred. So you have this additional information that the result of the first toss is head. Now you want to find what is the probability of getting at least 2 head. Now what will happen? Now the number of favorable cases. So number of favorable cases are what? See, now you know already that the result of first toss is head. So your sample space has changed. Your sample space is F. Your sample space is F because now your sample space has 4 items. Because the first result is head and the remaining 2 results could be anything. Okay, so that's why your new sample space has 4 elements. So this is your new sample space and it has 4 elements. Why? Because you know already that the first result is head. So that's why this is your new sample space. Now what are the favorable cases? The favorable cases will be, this will be favorable case head, head, tail. This will be favorable cases head, tail, head. This is not a favorable case. This is actually not a case because you know that this case will not occur. Because you know that the first result is head. This is also favorable. So the answer will be 3 by 4. This will be your answer. Okay. So you can see this will be your answer. Now you can see your probability has changed actually. Earlier your probability was 1 by 2. Now your probability is 3 by 4. So this is how conditional probability works. So what is conditional probability? Let's assume this is your sample space. This complete thing is your sample space. This is your event E. You want to find the probability of E, then what it will be? It will be cardinality of E divided by cardinality of S. This will be your probability. Basically number of favorable cases divided by number of total cases. So this is your probability of E. But now what is happening? Now you know that some event F has already happened. Some event F has already happened. Okay. So now so remember this answer was before you know anything. Now you have additional information that this event F has already happened. Okay. So now you want to find the probability of E given that F. This you want to find. Okay. So let's assume your F is this. Let's assume this is your F. Now notice one thing. Now your sample space has changed. Why? Because now your sample space is this F. Because you know that F has already happened. Means this is your new sample space. This thing is your new sample space. This red one. This is your new sample space. Okay. So basically your new sample space will be probability of F. This is your new sample space. Okay. Or you can say basically cardinality of F. You can say cardinality of F. And what do you want to know? You want to find what is the probability that E will happen given that F has happened. See, in this red area you want to find where is E happening. This E is happening in this common area. You can see this E is happening in this common area, means E intersection F. In this common area this E is happening. So what I can say this is our favorable case. This E intersection F, this is our favorable case, and this F is our total case. So our answer will be favorable case divided by total case. This is favorable case, E intersection F. Okay. And this is total case, PF. So this is how you can find the answer. So the answer, basically this is the conditional probability. Let me write down again. Probability of E given that F is nothing but probability of E intersection F divided by probability of F. This is your answer. This is your conditional probability. This is how you can find. So this is a very important formula. This is known as conditional probability. Okay. So anyway, this formula is very important. Basically probability of E happening given that F has happened, this will be probability of E intersection F divided by probability of F. Okay, you can directly use this formula and you can get the answer. Let's so this is your formula. Okay, now let's see example. Let's take this example. Okay, before I take this example, let me take my own example. Let's assume you are rolling a dice. Okay, so you are basically you are rolling a dice. Okay, you are rolling a dice. Then what is the sample space? The sample space you already know, 1 2 3 4 5 6. This is your sample space. Okay, now what is your event E? Event E is getting an even number. This is your event E, getting a even number. This is your event E. What is your event F? Event F is getting a prime number. Okay, so you can see what is event E. Event E is getting an even number, means 2 4 6. This is your event E. What is event F? Event F is getting a prime number, 2 3 5. These are the prime number. So this is your event E, this is your event F. Now I want to wait a second. I will have to write it again. Okay, so basically it got removed. Rolling a dice. You are rolling a dice and the sample space you already know. This 1 2 3 4 5 6. This is sample space, and the event E is getting an even number. This is the event E. What is event E? Event E is this event. Let's assume event P. Let's see event F. Let's call it event F. Event F is prime number. What is event F? That is nothing but 2 3, 5. So this is your event F. Now my question, the first question I want to ask is, what is the probability of E? Tell me, what is the probability of E? Tell me quickly. You can solve very easily. This is probability of E. Probability of E will be 3 divided by 6. क्योंकि number of favorable cases are 3, number of total cases are 6, so the answer will be 1 by 2. This will be your probability of E. Now my question is, probability of E given that F has already happened. Probability of E given that F has already happened. What it is? Try this. What it is? Here you can use the formula. The formula says that probability of E intersection F. Probability of F. Now probability of F you already know. What is probability of F? This is F. So the probability of F is nothing but 3 divided by 6. This is your probability of F. Let's find what is what is E intersection F. What is E intersection F? This is E. This is F. What is E intersection F? This is this. This is E intersection F. You can see. Focus here. This is E intersection F. So what is the probability of E intersection F? The probability of E intersection F will be 1 by 6 because there is only this one element, so 1 by 6. So this is your probability of E intersection F, and probability of F is 1 by 2, so the answer will be 2 by 6, that will be 1 by 3. This is your answer. Probability that E will happen given that F has already happened is 1 by 3. Okay. Monica, probability can never be more than 1. The probability can never be more than 1. Anyway, so this is how you can solve. So this is a very easy formula. You already know, like you can very easily find probability of F. You can very easily find what is E intersection F. Once you find E intersection F, then you can find the probability of E intersection F. So probability of E intersection F is 1 by 6. The probability of F is 1 by 2. The answer will be 1 by 3. Okay. Let me ask you next question. Next question is probability of F given that E. What is this? Probability of F given that E has happened. What is this? So you can try again very easily. Probability of F given E will be, the answer will be, let me write it. Probability of F given that E. The formula you can apply. F intersection E divided by probability of E. What is probability of E? See, E is nothing but 2, 4, 6. This is E. So probability of E is nothing but 3 divided by 6. This is probability of E, 3 divided by 6. What is F intersection E? F intersection E is this. So probability of this is nothing but 1 by 6. So finally, what will be your answer? Your answer will be, so again it will be 1 by 3. So this again will be your answer. Okay. So this is how you can find. Let's ask another question. The same thing you have. Okay. Now I am changing. This event E is this event E is this. This is your event E, means getting a 2. This is the event E. And event F is getting a 2, getting a 3, getting a 4. This is event F. Now tell me what is probability of E given that F. What is this? Answer this. What is this? Event E is given, event F is given. When you roll a dice, remember the sample space is this. Okay, the same sample space is 1, 2, 3, 4, 5, 6. Basically what you are doing, you are rolling a dice. Okay, when you roll a dice, then these are the possible outcomes. So this is your sample space. This is event. this event E is getting a 2, event F is getting 2, 3, 4, getting 2 or getting 3 or getting 4. This is event F. I am asking what is the probability of E given that F has already happened. You can very easily you can solve it. Just apply formula P intersection F divided by probability of F. What is E intersection F? This is E, this is F. What is E intersection F? E intersection F is this. What is the probability of this? This is nothing but 1 by 6, because this is the E intersection F. Remember, this is E intersection F. E intersection F is this. What is the probability of E intersection F? That will be 1 by 6, because there is only one element here. Sample space has 6 elements. Now, what is probability of F? Probability of F is 3 divided by 6. So what will be your answer? Your answer will be 1 divided by 6. So answer will be 1 by 3. You can see answer will be 1 by 3. Now I am changing the question. Tell me what is the probability of F given that E. Probability of F given that E. What will be the answer? Tell me. What will be the probability of F given that E? So it will be probability of F intersection E divided by probability of E. What is probability of F intersection E? The probability of F intersection E is 1 by 6 divided by probability of E. What is probability of E? Probability of E is also 1 by 6. This is event E. See, this is event E. So what is probability of E? This is 1 by 6. So the answer will be 1. You can see the answer will be 1. One thing you can notice, that probability of E divided by probability of E given F, this is 1 by 3, and probability of F given E, this is 1. So basically they can be same or they can be different. Like, so I can say that this thing may not be different. May not be same as this thing. Both can be different, remember. Okay, so this is your conditional probability. Try this question. What will be the answer of this question? Try this. So let's see. What is this saying? It is saying a bit string of length 4 is generated at random. Okay, so see the sample space. What is sample space? Sample space is bit strings of length 4. For example, 000, for example 0001, 0010, and so on. Total how many strings are there? Total 16 strings are there. Okay, you know that if you have 4 if you have 4 positions, then each position can be filled with 2 items, 0 or 1, 0 or 1, 0 or 1. So how many total strings you have? 2 into 2 into 2 into 2. So that will be 16 strings. This we have already seen. In the combinatorics, in the counting, we have already done this. So there will be total 16 strings. This is your sample space. Now he is saying that all the bit strings of length 4 are equally likely. Okay, so this is basically like every bit string is equally likely. Every bit string has equal chances. Now he is saying, what is the probability that it contains at least 2 consecutive zeros given that its first bit is 0? See, event E is this. Event E is this. It contains at least 2 consecutive 0, means at least 2 consecutive 0. This is your event E. And what is event F? Event F is first bit is 0. First bit 0. This is event F. Okay. So now, first of all, what is this probability of E? Let's find what is the probability of E. What is this? See, this is E. At least 2 consecutive zeros. So how many favorable cases are there? How many favorable cases are there? At least 2 consecutive 0. So maybe your 2 consecutive zeros are here. Okay. So you want at least 2 consecutive zeros. For example, maybe the first 2 things are 0. Now you can have anything. So basically I am counting how many elements are in this set E. So you can see here you can put anything because you have at least 2 consecutive 0. So such cases are 4. Now let's assume the first bit is 1. Okay, the first bit is 1, and now let's assume that the next, so it could be anything. Now okay, you have 2. Okay, so you can see now what can happen, like so here you have, so maybe your second bit is 1. Maybe your second bit is 1. Okay, the first bit is 0, the second bit is 1. Then what will happen? Then only one case is there. Okay, so now what you can do? So 0 0 1 0, maybe 1 1. Then you have one case. So you can see that mutually exclusive, all are mutually. So in this case you will get it when you have 1, and let's assume the next is 0. So what you can have actually here 1 0. If you have 0, if you have of course you cannot have 1, so you will have to have 0 here. Now you can put anything, so this will be 2 0 1, then you do not have choice. So these are the favorable cases. Okay, total 8 cases are the you can say these are the favorable cases. So 8 divided by 16, this is the probability of E. What is the probability of F? F is saying the first bit is 0, means the first bit is 0. So how many favorable cases you have? You have 2 into 2 into 2. So total 8 favorable cases you have. Again 8 by 16. This is F. So this is E, this is F. Now he is asking what is the probability of E given that F? This will be E intersection F divided by probability of F. First of all, what is E intersection F? E intersection F means the first bit should be 0. The first bit should be 0. Okay. So basically E intersection F will have these cases. So you have 5 cases. So this will be the probability of 5 divided by 16 will be the probability for E intersection F. And what is the probability of F? That we have already calculated, 8 divided by 8 by 16. So your answer will be 5 by 8. So this will be your answer, 5 by 8. Very easily you can find. Okay, it's not a complicated thing. Just you need to find the favorable cases and you divide it by total cases. So this will be the answer, 5 by 8. Okay, so you can check out this explanation. So the answer will be 5 by 8. Anyone has any doubt in this? Just combinatorics, we have already solved these type of questions. We have already done combinatorics, counting questions. Okay, in the combinatorics we have already seen all these concepts. So this is the answer, 5 divided by 8. anyone has any doubt, then you can ask. Let's see this next question. Try this. What will be the answer? Try this question. Try this. Okay, so wait a second. So Nirdita is asking the favorable cases we want to discuss. Okay, let's see. So the I think you are asking how many strings are there which have at least two consecutive zero. I think you are asking this. Okay, so how many strings have at least two consecutive zero? At least two consecutive zero. At least two consecutive zero. This you want to ask, right? So see, at least two consecutive zero. Now you have four positions. These are the four positions you have, and you want at least two consecutive zero. Now assume case one. Assume that the first two bits are zero. Now your work is done, because you wanted at least two consecutive zeros. So your work is done. Now you do not care what happens here. So how many four cases are? So you can see four possibilities are there. This type of, when the first two bits are 0 0, then total four possibilities are there. Okay, so the case 2 is saying that, now see, in the case 1 the first two bits are 0 0. Okay, in the case 2 what you can do, the first two bit can be 1 0. This is case 2. See, because first two bit you can take either 0 0 or 0 1 or 1 0 1 1. These are the four cases possible for the first two bits. Okay, so this case is different from this case. In this case the first two bit are 0 0. In this case the first two bit are 1 0. Now we want to calculate. So see, this bit cannot be 1. See, this cannot be 1. Why? Because if you put 1 here, then you cannot get two consecutive 0. So this cannot be 1. This has to be 0. So now you do not care what will happen here. So here two possibilities are there. Here two possibilities are there. So you have 2. What is case 3? Case 3 is first two bit are, let's assume first two bit are 0 1. These are the first two bit. Now you must get 0 0 here, because so basically there is only one way, because you must get two consecutive 0. So this is the only possibility. What is case 4? Case 4 is 1 1. Now again you must get 0 0 here. So you can see these are the bit strings you want, 4 2 6 and 8. So total 8 strings will be there which have at least two consecutive 0. So is this point clear, Nivedita? So this is how you can solve these type of questions. Sometimes you can sometimes you have to basically do this type of calculation. Okay, so now let's see this question. Next question. What is the conditional probability that a family, again the same actually there is nothing in these questions. You need to just apply the simple formula you have. So he is saying that what is the conditional probability that a family with 2 children has 2 boys, given that they have at least one boy. Assume that each of the possibilities is equally likely, where B represents a boy, G represents a girl. Note that BG represents a family with older boy, younger girl. GB represents a family with older girl, younger boy. So okay, what is the sample space? The sample space is boy boy, girl boy, boy girl and girl girl. These are the sample space. Okay, remember these are different. Why? Because here he is saying the girl is older, and the boy is younger. Here the boy is older or elder, whatever, and this girl is younger. Okay, so this is the sample space. Okay, now what is event E? What is event E? He is saying what event you want. Event E means what event you want. So you want the event this, with 2 children has a 2 boys. This is event you want. So 2 boys. So basically this is the event you want. And what is the event that is given? Given they have this. So this is the event it is given. This is the event that is given. They have at least one boy. At least one boy means you can see this is the event F. So this is event F, this is event E. Now he is asking what is the probability of E given the event F. So he has already given that this event F has already occurred. So what will be the answer? Answer will be E intersection F divided by F. What is E intersection F? E intersection F. E intersection F is nothing but BB. This is your E intersection F. What is the probability of E intersection F? That will be one element is here. Total sample space has 4 elements, so 1 by 4. So this is the probability of E intersection F. Okay. What is the probability of F? The probability of F is 3 by 4. This is the probability of F. So what will be the answer? The answer will be 1 by 3. So this will be the answer. You can also find what is the, tell me, next question I am asking, what is the probability of F given that E? What is the probability of F given that E has happened? Tell me what will be the answer. This you can again very easily solve. So what is this? This is nothing but probability of F intersection E divided by probability of E. This we have already calculated. This is here 1 by 4. So 1 by 4 divided by probability of E. Probability of E is also 1 by 4 because see this is event E. So probability of E is also 1 by 4. 1 by 4 divided by 1 by 4, answer will be 1. So this is how you can apply the conditional probability. Let's see, this is the answer. Now the next topic we will see is the Bayes theorem. What is this Bayes theorem? Okay, so the Bayes theorem is like this. Let me tell you, let me ask you a question and then we will solve. So the question is this. Let's assume you have a box. This is your box 1 and this is your box 2. In this box, let's assume you have 2 red ball and 3 green ball. In this box 2 you have, let's assume 3 red ball and 4 green ball. So this is the situation. Box 1, box 2, 2 red ball and so on. So this is the situation. Now my question is, what is the so first of all, what you will do? Okay, so this is the situation. Now you are going, what you will do? You are doing this. You will pick any of the box randomly. So basically the first thing that you will do is pick a box randomly. So you can pick any box. Okay, now basically in a room these 2 boxes are in a room there are these 2 boxes. You are going inside and now you can pick any of the box randomly. Then once you have picked a box, okay, once you have picked a box, now you are extending your hand and you are picking a ball. So you are picking a ball. Okay, this is what you are doing. Okay, this is the experiment that you are doing. So this is your experiment. Now my question is, what is the probability that you will okay, so basically after this experiment you get a ball and you come out of the room and you play your cricket or you whatever, okay, cricket or tennis, whatever you want to play. Anyway, so see this, I am asking what is the probability that you will get a red ball. Try this. What is the probability that you will get a red ball? Try this. Very easily you can see. Okay, this concept we have already seen. In the you need combinatorics plus probability. These two things you need. You need your knowledge of combinatorics, product rule, sum rule, summation rule, product rule, division rule. All these things we have already seen. Try this question, attempt it. Let's see. He is asking what is the probability that you will come out with a red ball. So this is what he is asking. See, he is saying that what is the probability that you will come out with a red ball. Okay, this is what he is asking. So what will be the answer? You must understand this is the experiment. Experiment is, first you will pick a box at random. So you can either, so basically what you are doing this. Pick a box and pick a red ball. So this is what you want. Pick a red ball. This is what you want. So pick a box and so this is AND. So because of this AND, the product rule means multiplication will come. So pick a box. You have two boxes, so you can pick any of them. So you can pick any of them. Okay, then you can pick a red ball. Then you need to pick a red ball. Okay. So what you can do, either you can pick a box 1 or you can pick box 2. See, when you are picking a box at that time, either you can pick box 1 or you can pick a box 2. Basically you can do like this. Either you can pick box 1 or means plus. I told you in the summation rule, I told you that for or this summation will come. So either you can pick a box 1 or you can pick a box 2. Okay. Now what is the now once you pick a box 1, then you can pick a red ball. So this is what is happening. So okay, basically now what is the probability of picking the box 1? That is half. This is the probability of picking box 1. Now once you have picked the box 1, then what is the probability of getting a red ball? The probability of getting a red ball is 2 divided by 5. Or you can pick box 2. Picking box 2 will take 1 by 2 because the probability of picking box 2 is 1 by 2. After picking this box 2, what is the probability of getting red ball? This will be 3 divided by 7. So this will be your answer. So your answer will be 1 by 2. You can take common. 2 by 5 plus 3 by 7. This will be your answer. So this is the probability of getting red ball. So this is how you need to solve. Okay, you need to use your knowledge of combinatorics and your knowledge of probability. Let me repeat it again. You want a red ball. Okay, you want to go out with a red ball. Okay, so but remember, you want to go out with a red ball. So what is the experiment? First you are picking a box at random. So what is the probability of picking the box 1? This is half. What is the probability of picking box 2? That is half. So this is the probability of picking box 1. Once you have picked this box 1, then what is the probability of getting a red ball? This will be 2 divided by 5. Okay. Or you can pick box 2 multiplied by 3 by 7. So you can pick box 2. The probability of picking box 2 is 1 by half, 1 by 2, and the probability of now once you have picked this box 2, then what is the probability of finding the red ball? This will be 3 divided by 7. So this will be your answer. Okay, this is how you can solve. Anyone has any doubt in this? We have just used our concept. I considered picking red ball from first box. No. See, in this question he has already given you that the experiment is pick a box randomly, then pick a ball. Okay, pick a box randomly, then pick a ball. Okay, so you pick box 1. So this is the probability of picking box 1. Okay, so this is how you can solve this question. Anyone has any doubt, then you can ask. Now the next question. So we have seen what is the probability of R. Now tell me what is the probability of picking a red ball given the information that you have already picked the box 1. This is the question. See, listen this question very carefully. Now I am asking what is the probability of picking a red ball given that you have already picked the box 1. What is this? What will be the answer of this? Let's see this. Now see, this is what it is saying. It is saying probability of R. So okay, actually this is happening. You are entering inside the room and you have already picked the box 1. This information is given. This information is given that you have already picked the box 1. Now I am asking what is the probability of picking a red ball. See, this is saying picking a red ball given that you have already picked box 1. So right now you have already picked the box 1. So right now already you are here. Now I am asking what is the probability of picking a red ball. So picking a red ball is the has this probability 2 divided by 5. Because you have 2 red ball, total ball are 5. So the answer will be 2 divided by 5. Again, see, Nilima is doing this mistake. Nilima, we don't require half now. Why? Because it is already given. It is already given that you have picked box 1. So right now you have already picked box 1. It's like I told you, you are sitting in one exam and in that exam someone has told you that the answer is even option. Okay. So in that situation, now your probability will become 1 divided by 2 because now you only need to consider those 2 even options. So similarly here you have already selected box 1. See, what is this? This is conditional probability. This is saying probability of picking red ball, pick red ball given that it is already given that box 1 is already picked. Box 1 is already picked. So this is how. So you already have this box 1 in your hand. Now only thing you need to do is pick a red ball. So what will be the probability? That will be 2 divided by 5. So this is how you can solve. Now let's see the next question. The same scenario is okay, 2 red ball, 3 green ball, 3 red ball, 4 green ball. The same scenario, box 1, box 2. The next question is what is the probability that, let's assume it is given that, okay, basically, okay, let's assume some players are okay here, okay, 2 players are here. Now you are going inside this room, but now okay, we don't know, these 2 players don't know what is happening inside this room, which box you took, okay, these things they don't know. But you are coming with a red ball. Right now in your hand you have a red ball. So now these two people, they know that Sarika, in the previous question the situation was different. In the previous question we don't know which box was chosen. Both box have the same probability, like either you can choose box 1 or you can choose box 2. But in this question, in this last question, it was already given that you have already selected box 1. So understand the like language of the questions. This is important. Okay, so in the second question basically it was given that you already have selected the box 1. You have already selected it. After selecting the box 1, now I am asking what is the probability that you will choose a red ball. Okay, so this is the language of the questions. Now let's see this question. He is saying that now basically, okay, you went inside this room, you came out, but when you came out, you have a red ball with you. Okay, no, in the last question it was you don't have to select a bag randomly. In the last question it is already given that you have selected bag. See, in the last question we were saying what is the probability of picking a red ball given that you have already selected box 1. In the last question we were saying that you have already selected box 1. You don't have to select box 1 again. I am saying that you have already selected box 1. Now what is the probability of R? This is conditional probability. You can see probability of choosing R given that box 1 is already chosen. So this is the difference between these two questions. In the first question I was asking PR. In the second question I am asking PR given that B1. So there is a difference between these two questions. In this question, when I was asking what is the probability of picking a red ball, in this question basically you can either choose box 1 or you can choose box 2. You can either choose box 1 or you can choose box 2. But in this question it is already given that you have already chosen the box 1. This is the difference between these two questions. Conditional probability means what is the probability of E given that F has already occurred. This event F has already occurred. Like this picking the box 1 has already occurred. Okay. So Sarika, Pooja, is it clear? Like, are you getting the difference between these two questions? Okay. Let's see now. So now you are going inside this room, you are coming out and you have a red ball with yourself. So these two people, they don't know what was happening inside this room. Okay, basically they don't know which box you chosen. Okay, so they don't know like box 1 or box 2, they don't know. Okay, so now the question is, given that you already have chosen red ball, it is given that you have already chosen red ball. Now they are interested, these two people are interested in finding whether you have chosen from box 1 or box 2. Maybe this box 1 is the box which is provided by college, and this box 2 is maybe the box which is they have already bought themselves. So you can see they are basically interested in whether you chose from box 1 or box 2, because they clearly gave you the instruction that you should take a college a ball from college. Okay, so something like that. Okay, so basically we are asking what is the probability given that you already have red ball in your hand. Okay, you already have chosen red ball. Now we are asking what could be the probability that you have chosen it from box 1. So see, you have red ball, but we don't know whether you took it from box 1 or box 2. This we don't know, but we want to know what could be the probability that you might have chosen it from box 1. So this is the question we are asking, the probability of picking ball from box 1 given that red ball is already chosen. So what is this? Now let's solve this. Okay, look at here, this again is a conditional probability. So what will the answer? Answer will be probability of B1 intersection R. Just apply the formula. This conditional probability, this we have already seen. The formula says that probability of B1 intersection R divided by probability of R. Okay, so this is the this is the conditional probability formula I have applied. I have done nothing, just conditional probability formula, because this is the formula, probability of B1 intersection R. So now first we will find what is B1 intersection R. Let's find B1 intersection R, probability of B1 intersection R. What is B1 intersection R? Okay, actually this formula I told you, this conditional probability formula, I told you one thing. Okay, focus here. This we have already discussed. Probability of E given F is nothing but probability of E intersection F divided by probability of F. This we have already seen. Now if I want to find this, basically if I want to find E intersection F, then what it will be? It will be probability of F multiplied by probability of E divided by F. So this form, actually this is the conditional probability formula that we have already seen. From this formula we can get this. Basically if we want to find probability of E intersection F, then what it will be? It will be probability of F multiplied by probability of E given F. This is how you can find. So okay, this we have already seen, and from this we can get this. Okay, now let's see what will be this probability of B1 intersection R. So what it will be? It will be nothing but we can solve it very easily. This will be probability of B1 multiplied by probability of R given B1. This is how you can solve. Okay, probability of B1 multiplied by probability of R given B1. Is it clear? Because okay, see, what is this probability of R given B1? Probability of R given B1 is nothing but probability of R intersection B1 divided by probability of B1. We want this value. Probability of B intersection R. We want this value. Then it will be nothing but probability of B1 multiplied by probability of R B1. R given B1. So what is probability of B1? Probability of B1 is half. Because you have two boxes, box B1, box B2. So the probability of B1 is half multiplied by probability of R given B1. So this we have already calculated. This is 2 divided by 5. In the last question, this we have already calculated. Probability of choosing R, given that you have already chosen B1. So this will be basically 1 by 5. So you got this value. Probability of B1 intersection R, this is nothing but 1 by 5. Divided by probability of R, this we have already found. In the first question, this we have already found. What was this? I think this was 29 divided by 70. This was 29 divided by 70. So this is your answer. This is how you can find the probability of B1 given R. Okay, don't worry, we will take more examples. Okay, nothing to worry. Let's take more example. Let's take next question. Let's assume yeah. Okay, so let's assume you are tossing three coins. You are tossing three coins, or you can say first, so coin 1, coin 2, coin 3. These three coins you have, three different coins you have, you are tossing them. Event E is that you got exactly one head. This is the event E. Okay, now event F is okay. So okay, what you are doing? Okay, let me tell you what you are doing. So you have these three different coins, you are tossing them, and the event is that you are getting exactly one head. This is event E. Now my question is, what is the probability that this event E occurred on C1? Are you getting my point? I'm saying, see, you are getting exactly one head. Now this head, maybe this head came on this, maybe this head came on this, or maybe this head came on this. My question is, what is the probability that this head came on C1, given that head has already come? Okay, so actually sorry, my question is, what is the probability that you have chosen C1 given that head has already come? Okay, wait a second, actually. Okay, wait a second. Okay, in this question basically I am asking this. You have three different coins. These three different coins you have in your, like, on the table you have these three different coins. They are sitting on this table. You are going and you are picking one coin, you are picking any of these coin you are picking, okay, you are picking any of these coin, then you are tossing it. So first you are picking them, then you are tossing them. Okay, after tossing them, now let's assume head comes. Let's assume after tossing them, so first you are picking them, then you are tossing them. Now let's assume the head comes. So we know that head has come. Now our question is what is the probability that this head came on C1? So this head came, this you know, but you want to find what is the probability that this head came on C1. Basically, what is the probability that you have chosen C1 given that this head has come? Okay, this is the question. Are you getting this point? Anyone has any doubt in this question? Very simple question. You have 3 coins, you are picking any one of them, then you are tossing. You know the result is head, so this is the only information you have. You know the result is head. Now we are asking the question, what is the probability that you have chosen C1 given that head has come? This is the question. So again here we will solve it very easily. You can solve it. See this. He is asking what is the probability of C1 given H. What is this? This is nothing but probability of C1 intersection H divided by probability of H. Right? First we will let's find probability of H. Let's find probability of H. Probability of H, what it is? See, basically we want to find what is the probability of getting a head. So either you can pick this, or you can pick this, or you can pick this. What is the probability of picking this? This is 1 by 3. What is the probability of picking this? This is 1 by 3. Now once you have picked it, now you can get a head. Or you can pick this and you can get a head. Or you can pick this and you can get a head. So this is your answer. Basically this is nothing but one. This will be just you add them, then you will get what you will get. You will get 3 times. So this will be your answer. So this is your probability of getting a head. Okay, this is the probability of getting a head. So we have calculated this. Let's calculate what is the probability of C1 intersection head. What is the probability of C1 intersection head? This we have already seen that the answer will be probability of C1 multiplied by probability of H given C1. This we have already seen this formula. So what is the probability of C1? That will be 1 by 3. What is the probability of H given C1? That is 1 by 2. Okay. So the answer will be 1 by 6. So this value, this value is 1 by 6 and divided by this value is 1 by 2. So the answer will be 1 by 12. 1 by 3. So the answer will be 1 by 3. So this will be the answer, 1 by 3. Anyone has any doubt? Actually, I think many people have doubt. So the answer will be 1 by 3. So let me repeat it. Let me repeat the formula. Some formulas that you have. First formula we have this. Probability of E given F. What is the formula? Formula is very simple. E intersection F divided by probability of F. This is the first formula that we have. Conditional probability formula. From this formula we can find PE intersection F, that is equal to P intersection F is equal to PF multiplied by PE divided PE given F. Okay, so this we can find. But remember one thing, this P intersection F can also see. Okay, let's see this. PF given E. What is this? This is nothing but PF intersection E divided by PE. This also we have seen. From here you can find this P E intersection F. Of course F intersection E, E intersection F both are same. So the answer will be PE multiplied by PF given E. So you can see this is conditional probability formula. From this formula all these things are derived. This is the only formula that you need to remember. This is the only formula. And this also we have explained. like we took the example to explain this formula. From where this formula came, I told you. So for example, this is your event E, this is your event F. You already know that event F has already occurred. Then what is the probability of that E is occurring? So this will be, this is the favorable cases and this is the total cases. So this is the favorable cases, this is the total cases. So you can see this, the proof also we have seen. Okay, and this is the conditional probability. From this you can derive these. Okay, if you already know this formula, then you can very easily you can derive all these formulas. Now this, let's see the Bayes theorem. So Bayes theorem is this. Let's see the Bayes theorem. So the proof of Bayes theorem actually we will see in the complete lecture, because right now we don't have the enough time to see the proof of Bayes theorem. So the proof we will see at a later point of time. But actually the Bayes theorem actually says that probability of E given F, probability of E given F, this can be written like this. So you can see this is the leave it a second, this is the, yeah, so this is our Bayes theorem. Bayes theorem says that probability of F given E, what is this? This is equal to probability of E given F multiplied by probability of F divided by this thing. Okay, let me explain. Okay, from where this formula is coming, so that you don't have to by heart. See, from where this formula is coming, let me explain. Now this is your event E. Let's assume this is event E, this is event F. Let me explain the proof of this formula. So now we want to find what is the probability of F given E. You already know from conditional probability, you already know that this is nothing but probability of F intersection E divided by probability of E. This you already know from conditional probability. Okay, you also know one more. So this you already know, and you also know one more thing, that E given F is equal to probability of E intersection F divided by probability of F. This you know, this you know. From this you can find this. So what is F intersection E, or you can say E intersection F, because E intersection F is equal to F intersection E, both are same. So this will be probability of E multiplied by probability of F given E. From here you can find this. So this will be probability of E intersection F. So this will be basically both are same. So probability of E intersection F will be probability of F multiplied by probability of E divided by E given F. So these two things are same. You want to find the value of probability of F given E. So you want to find this value, probability of F given E. What is this will be? You can divide this. So this will be probability of F multiplied by probability of E given F divided by probability of E. So you can see in the Bayes formula, if you see the top part, we have already seen the top part. This top part says that probability of F multiplied by probability of E given F. This top part we have already seen. This bottom part is actually nothing but probability of E. This bottom part is nothing but probability of E. Because how can you find probability of E? Let me explain. So actually I am giving the proof, so it might look a very hard thing to some students, because actually I am telling you the proof of this Bayes theorem. Of course, if you want, you don't need the proof of Bayes theorem. You can just directly remember the formula and you can apply it. Okay. So, but anyway, let me just complete the proof so that you don't feel that you need to by heart something. Okay. So let's try to find probability of E. This we need to find. Now this is your event E, this is your event F. So the probability of E will be the probability of F E will be nothing but probability of E given F or probability of E given F is not. So okay, are you getting with this point? See, let's assume we have this F, this event EF. I want to find the probability of E. Then what I can say? I can say that either this F has occurred or this F has not occurred. Of course, these two possibilities are there. Either this F will occur or this F will not occur. Okay, because these two possibilities are there, right? Okay, so this is saying that either the F has occurred or F has not occurred. So this is the probability of E given that F has occurred, or probability of E given that F has not occurred. So this is the probability of E. Okay, so let's check out. So here you can see now what is this? What is this? E given F. What is this? So wait a second. So yeah, actually sorry, I made a small mistake. Actually here I can say it like this. So you have this event E, you have this event F. What we are saying, what is the probability of E? So what is the probability of E? You know that either the event F has occurred or it has not occurred. So I can say event. So one situation is event F has occurred. So I can say that event F has occurred and E has occurred, or event F has not occurred and E has occurred. So these are the situations. So now what is this? Is it saying event F has occurred means probability of F multiplied by probability of E given that F has occurred, plus or means plus probability of F has not occurred. F has not occurred because either the F has occurred or the F has not occurred, multiplied by probability of E given that F has not occurred. So this is the probability of E. If you remember, okay, let me tell you. Okay, let me tell you that example that we took. Just remember that example that we took. We took this example where this box 1 was there. In this box 1 we have two red ball, 3 green ball. In this box 2 you have 3 red ball and 4 green ball. So just see this example. In this example, when I told you find the probability of R, find the probability of R. So now probability of R, what it will be basically? So the probability of R will be either you have chosen box 1 or you have not chosen box 1. So I can say the probability of choosing box 1 multiplied by probability of R given that box 1, or you have not chosen box 1. You have not chosen box 1 means probability of not choosing box 1 multiplied by probability of R given that you have not chosen box 1. This we did. If you remember, the probability of B1 was 1 by 2 multiplied by probability of R given B1 was 2 divided by 5 plus probability of not choosing box 1, probability of B1 bar. This is nothing but 1 minus probability of B1. The probability of B1 is 1 by 2. So 1 minus 1 by 2. So this is 1 by 2. So this probability of not choosing box 1 is 1 by 2 multiplied by probability of choosing red ball given that you have not chosen box 1. See, if you have not chosen box 1, so if you have not chosen box 1, then what it means? It means that you have chosen box 2. If you have not chosen box 1, then it means you have chosen box 2. So you have already chosen box 2. Now what will be the probability of taking a red ball? This will be 3 divided by 7. So this is how we found it. The probability of R. So actually we have applied the formula, the base formula. Actually I told you, because if you want to find the probability of R, then what you have to do? Either this event B will occur or this event B will not occur. If event B is occurring, multiply this with probability of choosing R given that B1 is occurring, or probability of B1 not occurring multiplied by probability of R given that B1 is not occurring. So this is how you can solve. I don't know how much you got it. So let's see the direct formula. Now actually I have given the proof, but I don't know how much proof you have gotten. Even if you did not get the proof, nothing to worry. This formula you can just of course if you got the proof, then you don't have to it won't be difficult to by heart this proof. It won't be difficult. If you did not get the formula, the proof, then this is a very important theorem. With this base theorem you can remember it. We have seen the proof also. Okay, but so or you can do one thing. You can re-watch the recording and you can try to understand the proof again. But anyway, if you do not get the proof, then you can just by heart this formula, this base theorem. This is a very important theorem, so you can by heart this one formula. Okay. And okay, let me tell you one more thing, that right now we don't have much time, so but on this Bayes theorem is so much important that in complete course we will see this Bayes theorem for around 2-3 hours. So complete 2-3 hours we will give, almost 3 hours we will give to Bayes theorem only. Okay, so there we will see the proof, again we will see the proof, we will take many examples, around at least 10 or 15 examples we will take, 15 examples. Okay, so right now actually we don't have that much time, in the crash course we don't have that much time, but still I have tried to give you the proof, so you can go through the recording again. If you have any problem in the proof, then you can just re-watch the recording. Okay, or you can just by heart this formula. So this, either you can just by heart this formula or you can understand the proof that I have given. Okay, so this formula is saying this: probability of f given E is equal to the probability of f given, let me tell you one by one. So this formula, how can you get it? This is just a conditional probability formula. Probability of f given E, this is nothing but probability of f intersection E divided by probability of E. Now what is this above thing? Probability of f intersection E, how can I write it? I can write like this: probability of f multiplied by probability of E given f. This also comes from conditional probability formula. Probability of f given E, f intersection E, this will be probability of f multiplied by probability of E given f. So this very easily you can find from conditional probability formula. What is this PE? This PE means either this f will occur or this f will not occur. If this f is occurring, then once this f has already occurred, then what is the probability of E? Plus, if this f is not occurring, then what is the probability of E given that f is not occurring? So this is your Bayes formula. So this is how you can understand this formula. Okay, so or you can by heart this formula. So that is your wish. Let's take one example on the Bayes theorem. Let's take one example. Try this question. In this question, let me explain. There is a box 1. In this box 1 you have 2 green ball and 7 red ball. There is a box 2. In this box 2 you have 4 green ball, you have 3 red ball. Now there is a person called Bob. He selects a ball by choosing one of the box at random. So what he does, he first chooses a box randomly. This is the first thing he does. Okay, the second thing, he will choose a ball from the box. Okay, choose ball. Now the question is saying that the ball that he has selected is red ball. So this is given to you. That the ball that he has selected is red ball. This is given. If Bob has selected red ball, so this is the information that is given to you. So this is the given information. He has selected red ball. What is the probability that he has selected a ball from the first box? So basically he is asking this: what is the probability that he has selected this red ball from the box 1, given that he has selected red ball? So this is the question he is asking. Let's see this question. So again we can apply the formula very easily. Probability of B1 given R, what it will be? It will be probability of B1 intersection R divided by probability of R. What is probability of B1 intersection R? That will be probability of B1 multiplied by probability of R given B1. Okay, so what is this probability of R? This probability of R is nothing but either you have chosen B1, or you have not chosen B1. If you have chosen B1, then the probability that you have chosen R from B1, or if you have not chosen B1, then probability that you have not chosen you have chosen R, given that B1 is not chosen. So this is your Bayes formula. I have just from here you can directly remember this thing, but anyway I just wanted to tell you how this formula is coming. 3 times actually I have repeated it, so this is the 3rd time I am repeating that this is how you can get. This is conditional probability formula, and from here you can get the Bayes formula. So this base formula is nothing but a formula that you get from conditional probability formula. So from this we have already seen, from here you can get it. Now this is the answer that you need. All these things you need, all these values you need. First let's find all these values. What is this probability of B1? The probability of B1 is 1 by 2 because you have two boxes. So this is the 1 by 2. What is the probability of R given B1? What is this? This is probability of choosing R given that you have already chosen B1. You have already chosen B1. So what it will be? It will be, see, given that you have already chosen B1, okay, now what is the probability of choosing R? So this will be 7 divided by 9. This will be 7 divided by 9. So this is your this value. So we have found this value. Now we have found this value. Let's find this value. So we have found this value also. Yes. Let's find this value. What is this? P B1 bar. What it will be? It will be 1 minus P B1. 1 minus P B1. 1 minus, what is P B1? That is 1 by half. So this is your P B1 bar. 1 by half. So we have calculated this P B1 bar. So this is 1 by half. What is this? This is P R B1. What is this? P R B1 bar. So what it is? It is saying that basically choosing red ball given that you have not chosen B1. B1 bar means you have not chosen B1. Okay. So if you have not chosen B1, then what you have chosen? You have chosen B2. See, if you have not chosen B1, then what it means? It means you have chosen B2. So from B2, what is the probability of getting red ball? That will be 3 divided by 7. So that will be 3 divided by 7. So you have this value, all the values you have, just put all the values in the formula. So the answer will be PB1 is 1 by half multiplied by PRB1 is 7 by 9 divided by PB1 is 1 by half multiplied by 7 by 9 plus PB1 bar is 1 by half and PRB1 bar is 3 by 7. So now you just calculate it. This is your answer. You can just calculate it. This will be your answer. Let's take next question. Yeah, let's take this question. Okay, this is a quite not an easy question. So before we see this question, let's take one. Okay, let's directly take this question. Okay, let's take it. So he's saying that suppose one person in 1 lakh has particular rare disease. Okay, actually this will be a very hard to understand this question. So what we do, let's take another question and you can try this question on your own, and we will so that you can practice. This question will be easy once you practice the base theorem enough. The formula we will apply, actually here the direct formula will be applicable. You just need to direct apply the formula. Okay, so let me solve it. Okay, anyway let me solve it. Anyway, this is the last question that in these slides. So let's solve it. He's saying, suppose that one person in 1 lakh has a particular rare disease for which there is a fairly accurate diagnostic test. Like the COVID is going on, so this makes sense. So he's saying that one in 1 lakh has a particular rare disease. So there is a disease. So you have 1 lakh people, and out of those people, one person has this disease. Okay, and for this disease you have a diagnostic test. Now he is saying that this test is correct 99% of time when given a person selected at random who has a disease. So basically if you already have a disease, okay, if you already have this disease and you go for testing, then 99% chances are there that you will get the correct result. Okay, so basically if you have a disease, if you have corona, let's assume you have corona, you are going for testing, then this test will 99% of time this test will give correct answer. Basically this test will say that yes you have disease. Okay, so 99% chance, but 1% chance is there that it will say that no, you don't have corona. So basically what it is saying like this: So first of all, what is the probability of this disease? Okay, you can say here he is saying that what is the probability of this disease? What is the probability of disease? So this is nothing but, so I can say probability of disease is nothing but 1 divided by 1 lakh. This is the probability of disease, because out of 1 lakh people only one person has it. So this is the probability of disease, 1 divided by 1 lakh. So this is PD. Now he is saying that let's assume you have disease. Let's assume you have disease. Okay, now you are going for testing. You are going for testing. Okay, now he is saying that 99% chance are there that yes will come, 1% chance is there that no will come. Okay, assume that you do not have disease. He is saying that assume you do not have disease. Assume you do not have disease. Now you are going for testing. Now you are going for testing. Then he is saying that 99%, 99.5% chance are there that it will say no, but there is 0.05% chance, sorry, 0.5% chance, 0.5% chance are there such that it will say yes. Okay, so this is the question. Actually this is the complete question. You can just read it. After this class is over, you can read it. Basically I have just written it, okay, in this diagram representation. So this is the probability of disease. And if you have disease, let's assume if you have disease, you go for testing, then 99% chance are there that yes will come, 1% chance is that the result will be no. If you do not have disease and then you go for testing, then he is saying that 99.5% chance the answer will be correct. The correct answer means no will come, and 0.5% chance is that then the answer will be yes. So you can see, so this is actually called false negative. This is called false positive. Actually, if you remember these terms, this is called false negative, this is called false positive. Anyway, now he is saying, the first question he is asking, what is the probability that a person who has test positive for the disease has a disease? So he is asking, what is the probability given that you already tested positive? So the test is positive, t plus means the test is positive. Now he is asking, what is the probability that you have a disease? So this is the first question. The probability that a person who has tested positive, so you have already tested positive, this is the given thing, you have already tested positive. Now what is the probability that you have this disease? So probability of D given T plus. So this is he is asking. Now what you can do, you can just apply the formula. Let's apply the formula. So he is asking the probability of disease given that you have tested positive. T plus means you have tested positive. Okay, so this will be again the conditional probability formula you can apply. This will be D intersection T plus divided by probability of T plus. What is D intersection T plus? This D intersection T plus is nothing but probability of D multiplied by probability of T plus given T. Okay, because from where this formula is coming, let me tell you from where this formula is coming. This is coming from our conditional probability formula, because if you have this T plus given D, what it will be? It will be T plus intersection D divided by probability of D. So you are just finding this, so you can multiply it here. So from there this formula is coming. Okay, that's why I am saying you don't have to by heart anything. You don't have to by heart this base formula. You can just solve it like this. So this will be probability of D multiplied by probability of T plus given that T. Now what is probability of T plus? See, two situations are possible. Either you have disease or you don't have disease. So either you have disease, now what is T plus D? Or you don't have disease, now what is T plus given D bar? So this is the base formula. So you can, if you do not want to by heart, then what you can do, you can go from here to here, then you can go from here to here. This is how you can do. Or you can just directly by heart. This is your wish, what you want to do. Either you can just directly by heart this formula, or you can understand this formula like this, from here to here, from here to here. Now let's find all these values. Let's try to find all these values. What is PD? PD we already know, because he is saying that 1 out of 1 lakh people have the disease. So the PD is already given as 1 divided by 10 to the power 5. This is the PD. This is already given. Okay, PD is given. What is P T plus given D? What is this? Probability of T plus given you have a disease. So this is already given in the question. He is saying, see, if you have disease, then what is the probability that you will test positive? This is 99%, means 0.99. This is the probability, 0.99, right? 0.99. This is your probability, 0.99. This is in the question. It is given that what is the probability that you will test positive given that you already have disease. So he is saying that if you already have disease, then what is the probability that you will test positive? So it will be 0.99. Now let's try to find. So this we have already found. This we have already found. What is this D bar? Probability of D bar is nothing but 1 minus probability of D. So probability of D we already know. So 1 minus 1 divided by 10 to the power 5. So we found this also. Now what is probability of T plus given D bar? What is the probability of testing positive given D bar? So given D bar means you don't have disease. You don't have disease. Now what is the probability of testing positive? This is 0.50. This is 0.50. So we have all these value. We have this value, this value, this value, this value, this value, this value. Now you can just put all these values and you will get the answer. Okay, so this is how you can get the answer very easily. Just this base formula, just direct putting the values. Okay, let's take the next part. This is the next part, part B. In the part B, he is asking the probability that a person who tests negative for the disease does not have disease. So he is asking that what is the probability that you don't have disease given that you are testing negative. So see, he is saying that the probability that a person who has tested negative, so it is given that a person has tested negative, it is given. Now he is asking what is the probability that the person who tested negative does not have the disease. So he is asking probability of D bar given T minus. So what will be D bar given T minus? Let me answer it. What will be D bar given T minus? Again, we can apply the conditional probability formula. This will be probability of D bar intersection T minus, or I can say T minus. Okay. Now, divided by probability of T minus. What is this above thing? What is this above thing? This is nothing but probability of D bar multiplied by probability of T minus given D bar divided by. What is probability of T minus? See, two situations are possible. Either you have disease or you don't have disease. If you have disease, then if you already have disease, then what is the probability of T minus? If you don't have disease, then what is the probability of T minus? So this is your base formula. So you can see every time I am actually I myself don't know the base formula. I never remember it. This base formula I have never remembered it. This is how I solve the question always. If you will give me any question, I will solve it like this. First I will do like this, then I will do like this. So this way actually I don't actually if you randomly come to me and you ask me what is the base formula, I can't tell you because I never by heart this formula. Okay, so that I will just do like this. First I will find this, then I will find this. This is how I will do. Now let's find all these values. What is PD bar? PD bar we already know. This is nothing but 1 minus PD. What is the PD? PD is nothing but 1 divided by 10 to the power 5, because out of 1 lakh people only one person has disease. So this is our 1 minus PD. What is P? T minus given D bar. This also has given. See here, if you don't have disease, then what is the probability of testing negative? So the probability is 99.5% chance. So you can say 0.995. This is the probability. So this already in the question he has given. So we have calculated this. Okay. So we have calculated this. Now let's calculate what is PD. PD, you know, PD is nothing but 1 divided by 10 to the power 5. What is PT minus D? PT minus given D. He's saying, what is the probability of testing negative given that you have disease? So given that you have disease, what is the probability of testing negative? The testing negative probability is 0.01. 0.01. So this is the, now you have all the values. You have this value, this value, this value, this value, this value, this value. You can just put all these values and you will get the answer. This is how this base formula is applicable. So you can just apply all these formulas and you will get the answer. This is the solution. Okay, today I will actually today our course is over, so today I will share all the slides. I always forget, I don't know why. So today I will do actually just after this class is over, I will share all these slides and you can go through this solution. You can see there is a very detailed solution. I have from this I have taken from Kenneth Rosen. Actually this example I have taken from the book Kenneth Rosen. From this book I have taken these examples. Okay, let's solve this question. Try this question. Suppose that E, F1, F2, F3 are events from a sample space S and F1, F2, F3 are pairwise disjoint. Their union is S. Find P F1 given E if all these values are given. So all these values are given. You need to find F1 given E. Khushbu, in the exam they will ask if it is a nice exam, if it is a good exam, like if it is a GATE exam type of thing. GATE or NET exam are actually nice exam. So they will make sure that you only know the concept. The calculations should be less. Because calculation anyone can do. Anyone can take a calculator and can do the calculation. So doing the calculation is not the thing that they want to know. They want to know whether you know the concept or not. Let's try to solve this question. Try this. All the values are given. You just need to apply the formula. The base formula you need to apply. All the values are given. Try this. Let's see. He's asking the probability of, he's asking F1 given E. So he's asking F1 given E. This is what he's asking, F1 given E. What is F1 given E? Just apply the conditional probability formula. So you will get it is F1 intersection E divided by probability of E. What is F1 intersection E? This is nothing but probability of F1 multiplied by probability of E division by F1 divided by probability of E. Let's see what is probability of F1. Okay, let's first find what is probability of E. The probability of E is, he's saying, see, this is your sample space. In this sample space, basically this sample space can be divided in F1, F2, F3. All these are mutually disjoint. In the question he is saying F1, F2, F3, all these are mutually disjoint. This is your sample space and the union of f1, f2, f3 is sample space. This is given in the question. These all things are given in the question. Now what is the probability of E? So the probability of E means either E can occur here, or E can occur here, or E can occur here. Means probability of f1 multiplied by probability of E given f1 plus either f1 can see f1, f2, f3 all are disjoint. F1, F2, F3 are disjoint. So if this is occurring, then this cannot occur. If this is occurring, then this cannot occur. So either this can occur. If this is occurring, then probability of E given F1, or this can occur. Probability of E given F2, or probability of F3 give probability of E given F3, because all are disjoint. So either this can occur, or this can occur, or this can occur. These are disjoint. So if this is occurring, then this will not occur. If this is occurring, then this will not occur. So what we can say? We can say either F1 can occur multiplied by E given F1, or F2 can occur given probability of E given F2, or F3 can occur probability of E given F3. All these values are given in the question. He has given probability of E given F1 is given, E given F2 is given, E given F3 is given, F1 probability is given, F2 probability is given, F3 probability is given. So in the question he has given this F1 probability given, E given F1 given, okay, this is given, 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 this is given. Just apply the formula and you will get the answer. Anyone has any doubt? So I can see students are not trying. Maybe let's take this example. Okay, let's take this example. What he's saying. Suppose that Frida selects a ball. Okay, let's do one thing. Let's see this example and let's try to understand the Bayes theorem again. So just focus on this question. We will see this question in a very detailed manner. Just focus here. Okay, for 5 minutes just give your full focus on this question and we will try to understand the Bayes theorem through this question. He is saying, suppose that Frida selects a ball by first picking one of the two boxes. So you have two boxes. One box is B1, another box is B2. She is saying that first she is picking a box at random, then selecting a ball from the box at random. Okay. The first box contains 2 white balls and 3 blue balls. The second box contains 4 white balls, 3 blue balls. 3 blue balls. He is saying like this. Okay. Now, what is the... Okay. No. Okay, what is happening? The first box contains 2 white balls, 3 blue balls. The second box contains 4 white balls, 1 blue ball. 4 white ball, 1 blue ball. Okay. Now he is saying, what is the probability that Frida picked a ball from the first box if she has selected a blue ball? So he is asking, you have already selected a blue ball. You have already selected it. This blue ball you have already selected. Now he is asking, what is the probability that you have selected it from box 1? So this is, he is asking, probability B1 given that you have selected blue ball. So let's see what is P. He is saying what is B1 given B. So again you can apply the formula. This will be B1 intersection B divided by PB. What is B1 intersection B? This is nothing but P of B1, P of B divided by B1. What is this PB? What is this PB? See, either you can select box 1 or you can select box 2. Either you can select box 1 or you can select box 2. See, remember this is like this. Or you can see, remember this PB2 is actually same as PB1 bar. So that's why you can write PB1 bar also. You can say either you can select box 1 or you do not select box 1. So both are same, because not selecting box 1 means selecting box 2. So you can do like this, PB1 or PB2. Now what is this? This is probability of selecting blue ball from B1, probability of selecting blue ball from B2. This is your base formula. This is your base formula. Okay. What is this probability of B1? The probability of B1, the box 1, this is half. What is probability of B selected from B1? Blue ball selected from B1. Blue ball selected from B1, this will be 3 divided by 5. Divided by. So this we have already, these things we already know. This is 1 by 2, 3 by 5. Plus, what is this? Probability of B2 means box 2. This is half. Probability of B from box 2. B from box 2. B from box 2. This is 1 by 5. This is your answer. You can just calculate. Now you can just calculate and the answer will be this. Okay. So anyone has any doubt? So the probability is over. The Bayes theorem. We have seen the basic probability, combinatorics, counting. The Bayes theorem we have seen independent events, disjoint events, mutually exclusive events, conditional probability. All these things we have seen. Any doubt, anyone? This probability is a tricky chapter, so you need a lot of practice. I suggest you watch the recording again. Okay, you can re-watch the recording, and this time what you can do, don't look at the solution, don't look at my solution, just try to solve it. Try to solve it on your own. You can just calculate it. Khushbu, you can you can just find, like, this is just a calculation. You can calculate it, and whatever is the answer. For example, the answer actually you can find it very easily. The answer is this. From here, what you can do, 2 by 5. So 2 by 5 will cancel. So 3 divided by, and this is 3 plus 2 by 5. So you can just calculate. So 3 plus 1. So this will be your answer. 3 divided by 4. This will be the answer. 3 divided by 4. Okay, so let's see the next topic, mathematical induction. This is remaining. Let's see, this is the, I think this is the last topic that is remaining. Before we see this topic, let me tell you one thing. So actually, because of the time issue, okay, because we have a very limited amount of time in the crash course, so that's why you can see for the Bayes theorem, okay, so for this Bayes theorem we have only taken around 5 examples we have taken. Okay, 5 examples we have taken, but in the complete course we will have sufficient amount of time. At that point of time, from this Bayes theorem I am going to take like 15-20 examples we will take. You can see we will take so many examples that you will just like at the end of these examples, like when we will see 19th 20th example, at that point of time this Bayes theorem will be like will become a 2's table for you, just like 2's table, 2 into 2, 2 into 3, 2 into 4 and so on. So you can see these many examples we will take. This Bayes theorem we will study around 3-4 hours. We can study at least 3 hours. We will study this Bayes theorem. These many examples we will take in the complete course. Right now actually the time is limited. We are doing the crash course because the NET exam is coming, so that's why these things we are looking in a quick manner, you can see. But still I am trying to take more examples for the complicated chapter. This Bayes theorem is a complicated chapter, so I have taken more number of examples, around I think 5, 6, 7 examples I have taken. So that is the reason. Let's take this mathematical induction. What is this mathematical induction? Let's assume you have a ladder. So this is your ladder, and okay, let's assume this is the ladder. Now this is like this. Now let's assume this is an infinite ladder. This is infinite. Okay, so now two things. So you are climbing this ladder. Let's assume you are climbing this ladder. You can do two things. You can do. Okay, we don't know whether you can climb this ladder or not, but you can do two things. You can do. The one thing, you can get onto the first step. So you can get onto the first step. This you can easily do. Get on the first step. This you can do. Now the second thing the second thing that you can do is, if you are on some step, of course if you are here, let's assume you are here, then you can just take the one more step, basically just one more step, just one more step you can take. Of course these two things seem like easy, because you can easily get here, okay, the first step you can easily get here. If you are here, then you just need to take a one step, just you need to go here. Oh, that's it. If you are here, then you just need to take a one step. So actually this is how, if you can do these two things, then you can climb this infinite ladder. So this is our mathematical induction. Mathematical induction says that if you can do this and you can do this, then you can climb this infinite ladder. Why? Because you can climb here. First you will climb here because you can do this. You are saying that you can do this. So this first task is done. Okay, you can do this. Now you are saying that you can do the second task, and the second task is just one more step. So if you are here, you don't look at the infinite ladder, just take one more step, so you can go here. Now if you are here, just take one more step, now you can go here. If you are here, just take one more step, you can go here. Just take one more step, just take one more step, just take, and so on. So this is how, using this is mathematical induction. Basically you can climb the infinite ladder. So this is the mathematical induction. So mathematical induction says, let's assume this is the situation. You have a library. In the library, let's assume these are the you can say, this is how the racks are there. Okay, so this is how the racks are there. Here books are there, again the books are there. Library has this type of situation, like books are there. So this is how. Now if you push this rack, then what will happen? This will fall on this. Now this will fall on this will fall on. So see, you just pushed this. You have only pushed this first ladder, this first rack. Okay, but what will happen now? This will push this will push this will push this, now, and so on. You can see automatically you only did this task, and automatically all these will fall. So this is mathematical induction. Basically mathematical induction says that you do a basic task, okay. Now once you do a basic task, this is the basic task you have done, okay, you can do. The second thing is, one thing will lead to another. So two things are required. The first thing is the basic task, and the second thing is one thing lead to another. Like here you can see, you have done this basic task. Pushing this was the basic task you have done. Now you can see one thing is leading to another. So what will happen? If these two things are true, then every rack will fall. You can see every rack will fall. Similarly, in your ladder example, you can see this is the basic task you are doing. This first step, get on the first step. This is the basic task you are doing. And one thing lead to another means, if you are here, then you can go here. Just one step. I can say like that, just one step. If you can do this, then what will happen? You will be able to climb the infinite ladder. This is your mathematical induction. Very easy thing, you can say, very easy to understand. Okay, so this is how you can understand. So if you can just take one more step, then you will see in no time you will be climbing the infinite ladder. That's why people say, all these motivational people, what they say that if you have a mountain of problems, let's assume this is the mountain of problems. Okay, you have in your life, you have these, let's assume this is the syllabus. This is a very, like, when you look at the syllabus, then it looks like a huge syllabus. It's a very huge syllabus. But what you do, just take a first step. Okay, study the mathematical logic. Now just take one more step. Now take one more step, one more topic. Automatically you will see after few days, this mountain will be over, you can see. So this is the mathematical induction. Okay, so this is how mathematical induction works. And actually all these motivational speakers, they are just telling you to do one more thing, take one more step, go one step forward. Okay, do something, do just little bit more. All these things actually are mathematical induction. Next time someone comes to you and gives you motivational speech, you can tell him that I know mathematical induction, you can go, I know how these things work, I don't need your motivation, and I will just apply this mathematical induction. So you can do like, anyway, this is your mathematical induction. Anyway, so what is mathematical induction? The mathematical induction is like this. You prove a base case, just prove a base case. This is your base case, means basic thing. This is your first step. This is your first step. You have taken the first step. Now one thing lead to another. So Pn will lead to Pn plus 1. Just show it. Just prove that one thing will lead to another. Just prove it. Just prove it. One thing will lead to another. You need to just prove it. Basically, you need to say that I can take the first step. I can study the first topic. Small topic I can study. The first topic I can study. And once I study this topic, then I will study the next topic. These two things if you can say, these two things if you can determine, or like with full dedication, if you can do these two things, take the first step, and what is the second thing? Second thing is take the next step. Okay, if you are here, basically if you are here, then just take the next step. If you can do these two things, then automatically you can do anything. Basically you can see this is mathematical induction. You can do anything. If you can do these two things, then you can do anything. Okay, so let's take one example. Let's prove that 1 plus 2 plus 3 and so on plus n is equal to n plus 1 by 2. This formula you might already know. This is nothing but an arithmetic progression formula. 1 plus 2 plus 3 and so on plus n. This is your mathematical induction formula, and you already know this thing, n plus 1 by 2. This formula you already know. Let's try to prove it. So 1 plus 2 plus 3 plus and so on plus n. This is your formula. Let's try to prove that this is equal to this. So let's try to prove. Again the same thing, very easy. Take base case, basic case. What is basic case? Very basic case. Take n equal to 1. Means prove that, let's call it P1, let's call it Pn, let's call it Pn. Pn means sum of first n natural number. You can see these are the first n natural number. 1, 2, 3, 4 and so on n. These are first n natural number. So this is the summation of first n natural number. What is this Pn? Pn is summation of first n natural numbers. Okay, so basic case, very basic case, P1. P1 means n equal to 1. When you put n equal to 1, then basically what you are saying summation of only the first natural number. So it is 1. When you take n equal to 1, then it will be 1. So this you have done very easily, P1 equal to 1. Now the next thing, so this basic case you have done. The next thing says that just prove that you can go one step ahead. If you are standing at n, then you can go to n plus 1. You just show it. Basically you need to show that if you have done Pn, then you can do Pn plus 1. Just show it. Basically you can just go one step further. You need to show. If you are standing here, if you have done Pn, then you need to prove that you can do Pn plus 1. So let's assume you have done Pn. You have done Pn means let's prove that Pn is true. Basically let's assume that Pn is true. So this Pn means 1 plus 2 plus and so on. Let's assume this plus n. This is true. So this is true. Basically you have done the Pn. Now this is true. We have taken this to be true. Let's prove that now you can do Pn plus 1 also. Let's prove. We will prove that you can do Pn plus 1 also. Let's see. What is this Pn plus 1? This is nothing but summation of first n plus 1 natural number. 1 plus 2 and so on plus n plus 1. This is your Pn plus 1. This you already know. This thing you already know, because you have already said that you can do Pn. So basically this Pn you already have. So this thing is nothing but n plus 1 by 2. This you already know, plus n plus 1. From here what you can do, you can take n plus 1 common, or you can take you can take 2, you can take LCM 2, and you will get n plus 1 plus 2n plus 1. Okay, what is this? This is nothing but 2. You can take n plus 1 common. What you will get? You will get n plus 2. This you will get, and this is what you wanted to get actually. See, this you will get. You will get this n plus 1, n plus 2 divided by 2. This is what you wanted to get, because you wanted that summation of n plus 1 natural number should be n plus 1, n plus 2 divided by 2. This is what you wanted. Finally you got it. So what you can say? You can say that this formula is correct. Are you getting my point? So basically this is the idea of induction. Induction, this mathematical induction is very easy. Just prove a base case. We proved P1. Now assume Pn is true. Assume Pn is true. This is your assumption. See, this is called base case. This is called base case. You have shown it. Now assume that Pn is true. Assume, this is your assumption that Pn is true. Now prove that Pn plus 1 is true. This is your mathematical induction. This complete thing is known as mathematical induction. Very easy. Just a fixed procedure. You can see we have a fixed procedure. Just prove base case. Assume Pn is true. Now prove that Pn plus 1 is true. Let's take next example. Let's prove that 1 plus 2 plus and so on, that is 2 plus n. Yeah, let's prove this. 1 plus 2 square plus 2 cube and so on, 2 power n. This is equal to 2 power n plus 1 minus 1 divide. So this is, let's prove this. So we need to prove this. Someone is telling you prove this thing. So let's see how you can prove this. Very easily you can prove this. First prove the base case. What is the base case? P1. Let's assume this is Pn. Let's assume this is Pn. So this is your Pn, because what is this Pn? Pn is nothing but summation, or basically you can see 2 power from 2 power 0 to 2 power n. This is your Pn, means from 2 power 0 to 2 power n. This is your Pn. Let's prove P1. What is P1? So see, this Pn is nothing but from 2 power 0 to 2 power n. This is your P1, from 2 power 0 to 2 power n. So how many terms are there? Total n plus 1 terms are there. Total n plus 1 terms are there here. Now what is P1? P1 means n. You are replacing this n with 1. So how many terms will be there? 2 terms will be there. So you will get 1 plus 2. This is 3. This base case is proven. Why? From you see, this is your base case. 1 plus 2. This is 3. Let's put n equal to 1 here. What you will get? You will get, let's put n equal to 1. Then you will get 2 power 2 minus 1. That is 3. You can see 3 equal to 3. So this base case is proven. This base case P1 is proven. Okay. Now let's assume Pn is true. Assume that this Pn is true. So let's take this to be true. Means assume that this formula is true. Assume this formula is true. Now we will show that what is Pn plus 1. Let's Pn plus 1. What is Pn plus 1? This will be 1 plus 2 square and so on, plus 2 power n plus 2 power n plus 1. This is your Pn plus 1. This you already have. This value you already have. What is this? This value is 2 power n plus 1 minus 1 plus 2 power n plus 1. So this value is you already have. This value you already have, and this is your this. From here what you can do? This is 2 power n plus 1, 2 power n plus 1. So this will be 2 power n plus 2 minus 1. You can just add this plus this is nothing but 2 power n plus 2 minus 1. This is what you wanted, because when you have n, when you have you can see when you have 2 power n, then the value was 2 power n plus 1 minus 1. When you have n plus 1, then the value is n plus 2 minus 1. This is what you wanted. So now you can say that this formula is true. So this is how the mathematical induction works. Okay, so these are the slides, and our complete discrete mathematics course is over. So we have seen many things. We have seen first we saw logic, then we have seen what is set theory, then we have seen group theory, we have seen graph theory. Okay, we have seen combinatorics, we have seen after this combinatorics we have seen probability, we have seen mathematical induction. All these topics we have seen. The previous year NET questions we have done for this. Previous year NET questions we have done here. We have done graph theory, previous year NET questions, and the previous year NET questions. Okay, only these two things we have done previous year NET questions, right? Only these two things. For these two things we have done the previous year NET questions. So now you can try to solve the previous year NET questions, and if you have any doubt, then you can ask right now. The next thing that we will start is TOC, and so if anyone has any doubt right now, then you can ask. Anyone has any doubt? So the discrete mathematics crash course is over. Some few things I would like to say. So this discrete mathematics crash course, this is over. Actually this crash course we have seen in quite detailed manner, I think. Okay, all the topics that we have seen them in a very detailed manner. But you can see in the complete course, actually all these things we will see in a like 3 times. You can see every single thing we will spend three times time. Okay, so right now, for example, on this mathematical induction we have just taken 2 examples. In the complete course we will take around 10 examples. So that is what going to happen. So almost 3-4 times things we are going to see. Okay, so here 2 examples, so you can just do the 3 or 4 times. So basically 6 to 8 examples at least we will see these things, maybe 10 examples, I don't know. Like once you understand the concept, once everyone will understand the concept, we will take those many examples. Okay, so तो कंप्लीट कोर्स के अंदर जो है ये सब हम करने वाले हैं. जब तक आपको समझ में नहीं आ जाएगा तब तक एग्जाम्पल लेते रहेंगे. ठीक है, जब तक फॉर एग्जांपल जैसे बेस थ्योरम है, अब बेस थ्योरम जब तक सबको समझ में नहीं आ जाए तब तक एग्जाम्पल्स लेते रहेंगे, बैक टू बैक 15 एग्जाम्पल 20 एग्जाम्पल, जब तक सबको समझ में ना आ जाए. ठीक है, इतने सारे एग्जाम्पल हम कंप्लीट कोर्स के अंदर लेंगे. तो कंप्लीट कोर्स में क्या है कि हमारे पास में डिस्क्रीट मैथमेटिक्स के लिए टाइम भी काफ़ी है. कंप्लीट कोर्स के अंदर हमें जो टाइम शायद जो अलॉटेड है वो मेरे ख्याल से शायद 50 आवर्स ऑफ टाइम इज अलॉटेड टू अस फॉर कंप्लीट कोर्स, ऑलमोस्ट 50 आवर्स. सो दिस 50 आवर्स इज अ लॉट ऑफ टाइम. Okay, so in the complete course we can see many more things. Okay, some concepts that are remaining, I think, like ring, field, all these concepts are remaining. So actually these concepts we will see in the solution session. Okay, so we will see the solution session of group theory, also the solution session of probability. All these things we can keep. Someday we will find some slot, we will find, and at that slot we can put the solution session of NET questions. So there we can see the remaining concepts. But if you like the crash course, then you can also this is your wish, you can try to like enroll in the complete course also if you want to. Okay, in the complete course we are going to I am going to teach discrete mathematics, TOC, DBMS and compiler design. These 4 subjects I will be teaching, and all these subjects we will see in such a manner that you will be able to answer each question from these subjects in your NET exam, GATE exam. I told you we will see all these things from GATE point of view. So once you study from GATE point of view, then you will be able to crack GATE also, you will be able to crack NET also. All exams you will be able to crack GATE, NET, NILIT, NIC, all these exams you will be able to crack after we go through these things. In the complete course, these are the things we will see. Okay then everyone, thank you. So we will start TOC after few days, I think from 23rd we will see this TOC. And so Pooja is saying TOC is very hard. So let me try. I will try to teach TOC in such a manner. I will try that you don't find it hard, because this is a very nice subject, very interesting subject, and I will try to make it easy for you. Okay. Okay then everyone. Thank you. If anyone has any doubt, then you can ask. See you in the next lecture. In TOC lecture, I will see you after 5 days. I think on the 23rd we have TOC. We will start TOC from the 23rd. So you can solve questions in these 5 days. You can solve discrete mathematics questions, and you can ask your doubts. Any doubt that you have, you can ask on the WhatsApp. You can ask, or in the next lecture you can ask. Okay. Thank you. Bye.